Hello viewers, in today's class we are going to discuss one important problem from functional equations, right? And here we have a problem in which the derivatives are also involved. So let us first read out the problem and then we'll see how we can solve this problem involving functional equations. So here we are given two functions f of x and g of x such that f of x is equal to e raised to 2x times g of x, right? And here we are given a functional equation f of x plus y is equal to f of x plus f of y, right? And g of 0 is given as 0, g prime of 0 is given as 4, and here g and g prime, that is the derivative of g, are continuous at x is equal to 0, right? So we have to find the function f of x, or in other words we can say that we have to find the form of f of x. So let us start with the definition of derivative of a function, right? Now see, we know that the derivative of a function f of x is defined by this limit, that is limit h tends to 0, and we have f of x plus h minus f of x divided by h, right? So this is the definition of derivative of a function f of x. So now here we have the term f of x plus h, right? So f of x plus h, and here we have the functional equation f of x plus y is equal to f of x plus f of y. So if we replace y by h, then we can write f of x plus h as f of x plus f of h, right? So let us substitute the value of f of x plus h in this limit, right? So we have f prime of x is equal to limit h tends to 0. We have here f of x plus f of h minus f of x divided by h, right? Now see, these two terms get cancelled. So we are left with limit h tends to 0, and here we have f of h divided by h, right? So now the value of f of h can be obtained from this equation, right? So here we have f of x is equal to e raised to 2x times g of x, right? So f of h is limit h tends to 0, and f of h is obtained by replacing x by h. So we have e raised to 2h, here we have g of h divided by h, right? So now f prime of x is equal to limit h tends to 0 e raised to 2h and g of h divided by h, right? So now in order to calculate this limit, we'll take help of the L'Hopital's rule, right? Now see, here the numerator is e raised to 2h g of h, right? So the numerator is given as e raised to 2h g of h. So when we take h is equal to 0, in the numerator we have e raised to 2 times 0 g of 0, and g of 0 is given as 0. So the numerator is 0, right? And the denominator is h. So when we take h is equal to 0, so the denominator also becomes equal to 0, right? So here we see that in the L'Hopital's rule, we are getting the 0 by 0 form, right? So what we will do, we'll differentiate the numerator and denominator with respect to h and separately, right? So we'll separately find out the derivatives. So we have limit h tends to 0. Here we have f of x, and To find out the derivative of numerator, we'll apply the product rule. So here we have e raised to 2h, then we have g prime of h, then we have g of h, and then we have the derivative of e raised to 2h as here we have e raised to 2h, then the derivative of 2h is 2, and in the denominator we have the derivative of h as 1. So now we have f prime of x as e raised to, here we have the limit notation. So limit h tends to 0, we have e raised to 2h, and we can take e raised to 2h common. So we have g prime of h plus 2 times g of h, right? So now let us take the limit here. So f prime of x is equal to, taking h is equal to 0, here we have e raised to 0, then we have g prime of 0, then we have 2 times g of 0, right? So f prime of x is equal to, e raised to 0 is 1, g prime of 0 is given as 4, right? So here we have 4, and 2 times g of 0 is 0, right? So now we have f prime of x is equal to, this is 0, so we have simply 4, right? So we have obtained d by dx of f of x is equal to 4, right? So now here we have a differential equation. So now integrating both sides, so we have d by dx of f of x, here we have dx, and here we have 4 dx, and c is the constant of integration, right? So here the integral of the derivative of f of x is the function itself. So we have f of x, and here we have 4x plus c, right? So f of x is a linear function in x. So now let us find out this constant, right? So in order to find out this constant, we'll make use of the boundary conditions. So here we are given that when x is equal to 0, we have f of 0 is equal to 4 times 0, and this is the plus c, right? So c is equal to f of 0, right? So our constant of integration is equal to f of 0, and f of 0 can be obtained by taking x is equal to 0 in this equation, right? So see, for x is equal to 0, here we have f of 0, and we have e raised to 0, because taking x is equal to 0, 2 times 0 is 0, and here we have g of 0, right? E raised to 0 is 1, g of 0 is 0, so here we have 1 times 0 is 0. So f of 0 is equal to 0. So the value of c is equal to 0. Taking c is equal to 0 in this equation, we have f of x is equal to 4x plus 0. So f of x is equal to 4x, right? So this is the form of the function f of x. So viewers, here we have seen that the form of the function f of x is a linear function, right? So f of x is 4x. Now let us find out the form of the function g of x. So taking f of x in this equation, we have 4x, and we have e raised to 2x times g of x. So g of x is equal to 4x divided by e raised to 2x, and this can be written as 4x e raised to minus 2x, right? So the function g of x has the form 4x times e raised to minus 2x, right? So viewers, this is a very interesting problem, and we have seen that how we can find out the solution of this problem by making use of the definition of derivative of a function and other concepts.